Alright guys, welcome to this page of the notes, and again what we're doing is we're sort of refreshing ourselves on how dilations work and checking to see if we can figure out whether diagrams or certain figures are similar. Now this one, I'm going to do what I've done again is I've given you a coordinate plane. I've drawn two figures on there, rectangle A, B, C, D, and rectangle E, F, G, and H. I want to know, are these figures similar? Now, before we go ahead and go through all the work that we did on the last page, I do want to remind you of one additional thing, sort of a shortcut, although it doesn't really save you from still having to show some of this work, especially if you're taking this class with me. On my test, I will ask you questions specifically that'll force you to do this, but there is a shortcut. Remember, if it's a dilation, you will be able to draw a line through corresponding vertices, and those lines will intersect at a point of dilation, right? The center of dilation. Well, here we go. Just real quick, check this out. I'm going to go ahead and draw a couple of lines through corresponding vertices. E and A are corresponding. So from E, that was off. Hang on, let me try again. E to A, awesome. Again, freehanding it, but it winds up there at the origin. C and G, G and C are corresponding vertices, so I would draw a line connecting those guys, and again, winds up at the origin. So far, so good. It looks like these lines are all going to intersect at the origin. FB, corresponding vertices, draw a line through those. Oh, shoot. Well, bummer, it doesn't look like the, well, maybe, let's see. Maybe I made a mistake. We got one more. H and D, corresponding vertices. Ugh, bummer. Okay, so right away at this point, I know. Are the figures similar? Why not? Well, because when I draw those lines through corresponding vertices, they do not all intersect at a point of concurrency. They don't all meet at the same point. What that means then is that I do not have a center of dilation, which means it cannot possibly be a dilation. Now, let's run through this and show you why that is. First, corresponding angles. Well, in this case, they're all rectangles, so that's easy. They're all 90 degrees. Angle A is congruent to angle E, and they're 90 degrees. Let's see, angle B is congruent to angle F, and they're 90 degrees. Angle C is congruent to angle G, once again 90 degrees, right? You don't need a protractor for this. You can see that the adjacent sides, one's vertical, the other's horizontal, they have to be perpendicular, and of course perpendicular is 90 degrees. Angle D is congruent to angle H, and once again 90 degrees. So here's what I know. Because all the angles are the same, I have the same shape. They are both rectangles. So far what I'm getting here is it looks like I'm going to run into an issue when it comes to finding the scale factor. So let's find out. Again, AB corresponds with EF. So EF over AB, and the nice thing about this, both horizontal lines, so you can simply count them. That EF is 7, AB is 4, and there's no real way to reduce 7/4 without giving yourself a decimal, so I'll just leave it as 7/4. The next one would be FG and BC. So FG and BC. Well, FG is 5, BC is 3. Again, all you got to do is count. 1, 2, 3, 4, 5. That's FG. BC is 1, 2, and 3. 7/4 and 5/3. Are those equal? No. No, they're not. And at this point, you can go ahead and stop. As soon as you set up those ratios and they're not the same, you do not have a common scale factor. No common scale factor. Because I have no common scale factor, it cannot possibly be a dilation. So here's what I know. Are the figures similar? No, not similar. Are the figures congruent? Well, you just look at it. No, they're not congruent figures. The angles and the lengths are not the same. So no, they are not congruent. And that's it, right? So again, just sort of as a review here, the things you need to do. First, you need to show that all the angles are the same, right? A dilation will not change the angles. In fact, none of our transformations will change the measure of the angles. Cannot change the shape. But what it will do is change the length of the sides, but it'll do it by the same ratio for all corresponding sides. And as soon as I get different ratios, I know that it can't possibly be a dilation. All right, what we'll do on the next page of the notes is now we'll take a look at how we can use some algebra to set up proportions to allow us to solve for unknown measures. I'll meet you guys on the next page.